Okay, on this helicopter problem, basically what I would look at is it sounds like you figured out number one and part of two to figure out the acceleration of the object. So I'm just going to kind of go into those again. So looking at the forces acting on the helicopter, you would have some kind of lift force. And then other forces that would be acting on it is you'd have the tension in this cable is actually pulling it down, and you would have the weight of it pulling down. Now I can find that force of gravity because it's 150 kilograms times 9.8, so I can get that, that's 1470. So I've got that. The tank is another one that we're going to draw a free body diagram on. Now it, because of Newton's third law, it would have a force up that's also tension. So the tension in that string pulls down on the helicopter, but it lifts up on the tank, and then you have a downward weight of the tank. Force of gravity on the tank, which would be 40 times 9.8, or 392 newtons. So that's the first part. You also mentioned that you figured out the acceleration. So the acceleration I would probably use would be this equation, vf squared minus vi squared over 2x. Now what I did is, since everything is descending in this particular problem, I treated everything as negative. So the final velocity is -2 meters per second squared, or meters per second, and that quantity is squared. And then I'm going to subtract the -5 squared over, I'd have 2 times -20, because I was treating anything downward as negative, so anything upward was positive, is the way I was doing it. And so I figured out the acceleration. Hopefully you got the same answer, 0.525 meters per second squared. Whoops. And I got it to be positive. Whoops, there should be a 0 in front, not a 5. 0.525 meters per second squared. It's positive because as this thing is descending, it's slowing down. So the acceleration is in the opposite direction of the actual object. So that's the first part. Now we're dealing with B, C, and D. I would actually do C before I would do B, because when I look at all the forces acting on my helicopter here, I have this situation that is going to make it a little more difficult. So for the helicopter, I have the lift force is upward, but then I have the tension, which is downward, and I have its force of gravity, which is downward. And that's, so the sum of all the forces, that's the sum of all the forces, and I'm treating the downward ones as negative, should equal mass of the helicopter times acceleration. So to find that lift force, I basically am going to add these things to the other side. So the lift force would equal the mass of the helicopter times acceleration plus the tension force plus the mass of the helicopter times the acceleration of gravity. That's just my FG here. So I just wrote it out longer. So we've got that number already, so it's not a big deal. The problem is I can't solve this. This is part B. I can't actually solve that until I find that tension force. So what I did is I actually borrowed the bottom with the tank and tried to figure out what's going on for part B. And so here, or for part C, to find the tension in this cable, I said that you would have an upward tension. So the sum of all the forces on the tank would equal a tension which is upward, but then it has its weight acting downward, and that should equal the mass of the tank times the acceleration. So if I rearrange this, I should be able to find the tension, because it should be the mass of the tank times acceleration plus the weight of the tank, which is going to be the mass of the tank times gravity. So this is how I would find part C, and that would find my tension. Then I can actually answer part D as well, because we're looking at how it compares to 500 newtons. And doing my math, I actually got it to be less than 500 newtons. So it's not in danger of breaking. And then I can substitute that tension in there, and I've got all the other numbers, and I should be able to find the lift force. So I would actually do this by finding the tension in the cable first, and then come back to find B, the lift force. Hope this helps on this problem.